Greetings, math fans. Alright, so this is Note Sheet 3, and our topic is conditional probability. Alright, so let me just kind of read off a couple things here. Conditional probability of an event B in relationship to event A is the probability that event B occurs given that A has already occurred. Alright, so the best example I can give you guys is if I pick something has occurred already. Okay, so that's why I even kind of say event A has already occurred. So the probability changes based on what event A happened. You know what happens with event A. So for example, if I have 52 cards and I pick a king, what is the probability that I'll pick another king? Well, I only have 3 kings left. But what happens if instead of picking a king first, I picked a queen? Well, now I've got 4 kings to pick from, so the probability changes. So based on what event A was, what I did before changes the probability of event B. Okay? So that notation is this. Okay, it's probability, it's B, and that's a vertical line A. So we say that is, or that's pronounced the probability of event B given A. Okay, that little line, this line means given. Alright, so that line right there means given. Okay? Alright, so let's just look at some probabilities. When two events A and B are independent, the probabilities of both occurring is, this is what we learned before. Probability of A and B is probability of A times probability of B, which makes sense. Okay, so those are independent events. So in other words, if I picked a card out of the deck and I put it back, and I picked another card out of the deck, they're completely independent events because I put everything back to normal again and nothing has changed. Okay? So that is our independent events, which we talked about in the past. All right? When two events A and B are dependent, the probability of both occurring, now this is a little bit different. So now you have probability of A occurring right here times the probability of B occurring given that A occurred already. Okay, so the probability is just a little bit different, and this is our only difference here is this probability of B versus probability of B given that A has occurred already. Okay, so they're both very important equations, both different a little bit. I mean, they're kind of similar, but these are our two equations. And basically this bottom equation down here, math fans, is basically solving for probability of B given A. Alright, so these two equations are really the same equation. It's just I'm solving for the probability of B given A. Okay? Alright, so let's see how we're going to use this. Alright, so first I just want to erase some of this stuff here so it's clear. Alright. If Billy Bo Bob, ooh, that's a good name. I like that. Hey, Billy Bo Bob. If Billy Bo Bob asks the prom queen for a date, there's a 60% chance of her saying yes. So if I would write this out in probability form, first of all, if Billy Bo Bob asks her for a date, so this is given. He's asking her for a date. If he asks her for a date, there's a 60% chance that she's going to say yes. Okay? So this is your probability right here. So here, this is what it looks like. It's the probability that she says yes, given that Billy Bo Bob asks her. That's the notation. Alright? Does that make sense? So the probability that she says yes, given that he asks her, is 0.60. Alright? The probability, and then the second part here, it says he is kind of shy, and so there's a 40% chance that Billy Bo Bob will actually ask her. So the probability that he asks her is going to be 0.40. Okay? And they want to know the probability that he asks her and she says yes. And the reason I say that's what I'm looking for, it says, what is the probability that they will go on a date? Well, how are they going to go out on a date? Okay, they're only going to go out on a date if he asks her and she says yes. Okay, so both of those have to be true. And so what we're going to do is we're going to look at this guy right here. The probability of A and B is the probability of A, which is 0.40, times the probability of B given A. So yes, given that he asked her, so 0.60. And so my answer for this one is 0.24. Let's just talk about how logical that answer is. Do you guys agree that he's got to ask her for a date, first of all, and then there's a 60% chance of her saying yes? The probability that he's even going to be bold enough to ask for a date is 0.4. That's pretty low. It's less than half the chance that he's going to ask her for a date. And then if he even asks her for a date, that's a little bit more chance that she's going to say yes. So that's why the probability is actually kind of low, because he not only has to ask her, but she's got to say yes. And those both probabilities are all both, one's less than 50%, one's greater than 50%. So it's 0.24. So it's pretty low that they're going to go on a date where everything's going to be true. Okay? All right, so let's look at example 2. You go to CarMax to buy a used car. And guys, don't buy a new car. Remember, it's a terrible investment. We talked about this already. A new car is a horrible investment. As soon as you drive off the lot, it's worth like 10 to 20% less than what you paid for it. Horrible investment. Okay? All right, so 30% of the cars are stick shift, which is awesome. I love stick shift. I have a stick shift. If you know how to drive stick shift, nobody can borrow your car. That's really nice. And it's fun. It really is. It's, you got to learn it, but it's fun. And if you don't know how to drive a stick shift, send me an email a couple days before you're going to go, to buy that stick shift car. I will meet you at the dealership, and we will learn how to drive stick shift right away. Okay? All right. Anyway, back to the problem. Sorry. It says 30% of the cars are stick shift. So let me write some of the probabilities out here. Okay. So probability that is a stick shift is 0.30. Okay. The probability that's a convertible, convertible, nice, is 0.40. And probability of stick and convertible is 0.15. So it says you definitely have to have a convertible. If you you have to have a convertible. That's given. That's given information. And then they ask you, what is the probability that the car comes with a stick? Okay, so this is the notation. What's the probability that the car is stick shift given that's convertible? Pretty straightforward, right? Well, remember, this is kind of like probability of A given B. So if I go back up to the top here, do you guys agree that I'm looking for, here it is, probability of A given B. And I want to point one thing out to kind of help you with the equation. This A right here is always this A here. This top part, that can be also probability of B and A. It doesn't matter, right? If you say B and A or A and B, it's the same thing. Okay, but that A needs to match up with that A in the denominator. All right, so I need probability that it's a stick shift and a convertible. So let's go down here. Probability that's a stick shift. Probability it's a stick and convertible divided by the probability it's convertible. Okay, we got all that. We got 0.15 is both, and divided by probability convertible is 0.40. So I divide that out, and I get 0.38. Okay, if the problem was a little bit different, it says the probability that it was, in other words, I had to have a convertible instead. Or, I'm sorry, I had to have a stick shift. What's probably it was a convertible? It would be a little bit different. It would be probability of the convertible given that it's stick shift which changes a little bit. It's the same on top, so probability of stick and convertible divided by, now it's probability of stick. Okay, so it changed a little bit. It would be, instead of 0.15 divided by 0.4, it would be 0.15 divided by 0.30. Okay? All right, cool. So let's go on to the next example. Now this is based off of a chart, which is kind of good because I want to show you guys how to figure out probabilities based on a chart, but also just based on probabilities. Okay? So here's a chart. It says basically I'm giving you right-handed people, left-handed people. That's my columns. And then my rows are females and males. Okay, so in other words, you can say a right-handed female is 60 of them, and a left-handed female is 20 of them, but there are 80 total females. Okay, but the total number, this is pretty important guy here, the total number of people is 130. Okay, which is good for our denominator. All right. Okay, so a student is selected at random. What is the probability that the student is a female? Well, how many females are there? Well, do you guys agree there are 80 females? Out of how many? 130. So that's it. 80 out of 130. Right? Pretty easy. And, you know, again, if you convert that into decimal, depending on what I'm asking for, it's 0.62. Okay? What is the probability that the student is left-handed? Well, how many left-handed kids do I have? I have 30 left-handed out of 130. So 30 out of 130, which gives me 0.23. Okay? All right, so the next one is a little trickier, but it's not that bad, actually. I'm going to show you using the chart and using the formulas. So what is the probability that the student is female given that the student is right-handed? So let's write that out here. The probability that the student is a female, so female, given that the student is right-handed. Well, that's using our formula, probability of a female and right-handed divided by the probability of, remember that goes with that, of right-handed. Okay, so let's do that. Probability of female and right-handed. Now, again, we're talking probabilities, so let's do that. So we have female and right-handed. So do you guys agree it's 60 female right-handed? So actually, let me erase this other stuff here. Okay, so female and right-handed is 60 out of 130. So let's write that in there. It's equal to 60 over 130. So it's female and right-handed divided by the probability of right-handed. Well, how many right-handed people do I have? 100, right? I have 100 right-handed out of 130. So let's do that. Divided by 100 over 130. What happens to 130s? They cancel. And you wind up with 60 over 100, which is 0.60. All right? So that's me showing you that with probabilities. I can ignore that 130. I want to show you why. If I just said probability of a female and right-handed, look at female and right-handed is 60, and then the probability that the student is right-handed. So right-handed is 100 over 130. All right. So I could have just did 60. So that's all I did here. Let me just highlight this. Female and right-handed divided by right-handed. I didn't even need to use that 130 at all, right? Because it cancels out anyway. So it's pretty sweet. So if I ask you what's the probability of getting a male that's left-handed, given that they're left-handed, you don't need to use the 130 anymore. You literally just can use these numbers. Okay? So it would be, for like, let's just do male left-handed, it would be 10 over 30. Okay, instead of saying 10 over 130 and 30 over 130, you can just say 10 over 30 because the 130s cancel out. Okay? So now let's actually use the chart, which I like the best. It's the most logical way is the chart. So here's the deal. Let's go look at the problem again. Okay? It says, what is the probability that the student is female given that the student is right-handed? So guys, I'm telling you that the student is right-handed. So this is the pool of numbers or the pool of people I'm pulling from, and then I'm saying, well, now what's the probability that they're female given that they're right-handed? So let's look at the chart again. Okay, I'm going to erase this other stuff here. All right, so if I tell you that they're right-handed, how many people do I have to choose from? 100. You guys agree with that? I'm telling you they're right-handed, and what is the probability that they're female? Well, there's 60 females out of that group, so it's 60 over 100, which is exactly what we got, 0.60, right? It's the same thing as we got up here. Logically, it's really an easy problem to do. All right, again, this bottom number, or I should say this value right here, the given is going to be the denominator, basically. Okay, the given is going to be the denominator. Remember when I taught you guys probability, I said it's the success over the total. That's why that given is the total. I'm telling you that the student is right-handed. So that's your total. That's your denominator, which is 100 people that are right-handed. And how many people are females that are right-handed? Well, it's 60. Okay? Not bad. So let's take a look at the next one here. If I knew a student was male, so again, I knew the student's male, so this is given. What is the probability that the student was left-handed? So my math statement here, the probability that they're left-handed given that the student's male. Again, I don't need the formula. I know the student's male. So let's see how many males we have. Okay, so we have 50 males. I know there are 50 males, and how many are left-handed? 10. Okay, there we go. 10 over 50. What? 10 over 50, which is 0.2. 1/5. It's really pretty easy. Okay? So just think logically. I mean, for like the first few questions, you kind of had to know the formulas a little bit to do this problem. But for the chart, you don't really know the formula. Just think logically of the given. There's my pool of numbers I'm choosing from, and then you get your numerator saying, what are you choosing? Are you choosing male or female or right-handed or left-handed out of that group? Okay? All right, cool. So let's keep going here. Last example. Doug has a closet full of multicolored clothes. So he's got a bunch of different colored ties, different color shirts, different color pants, and different color shoes. It says find the probabilities of getting the probability of blue clothes. Well, first of all, if I counted the number of items, there are 11 items here. Okay, so I'm going to write this out. 11 items. And that's going to come in handy when actually I work on my denominator. So what's the probability of blue clothes? Well, there's a blue tie, blue shirt, blue pants, blue shoes. So there's 5 out of 11. So I'm going to leave them all in fraction form just to keep them that way, okay? So 5 out of 11, that's pretty easy. What's the probability of getting a tie? Well, how many ties are there? 1, 2, 3, 4, right? 4 ties out of 11. Right? Not bad. Okay, the next one is a given. What's the probability of finding blue clothes given that it's a tie? Well, again, it's a tie. Remember, that given means that's my denominator because that's the amount I'm pulling from. That's the pool. So given that it's a tie, how many ties are there? 1, 2, 3, 4. So there are 4 ties. And how many blue ones are there? 1, 2. Here we go. That's the probability, 1/2. Not bad. Okay, the next one. What's the probability it's a tie given it's blue clothes? Well, how many blue clothes are there? 1, 2, 3, 4, 5. There are 5 blue clothes, and how many are ties that are blue? Well, 1, 2. So the answer is 2/5. Okay? Keep going here. the probability that the shirt is, or the probability it's an orange piece of clothing, given that it's a shirt. Well, how many shirts do I have? 1, 2, 3, 4 shirts. I have a blue, a red, a green, and orange. So there's 4 blue shirts, or sorry, 4 shirts, and how many of them that are orange? 1, right? 1 orange shirt. So there you go. Right? So again, I'm telling you it's a shirt. So you basically are looking at shirts. And I've got 4 shirts in front of me. And then I say, well, if this problem was completely different, I just said, here are some shirts, what's probably picking an orange shirt? You're like, oh, well, there's only 1 orange shirt out of 4, so I guess it's 1/4. And that's what you do. Okay? Probably it's a shirt given that's orange clothing. So now I'm telling you it's orange clothing. The only one that is orange clothing is this guy right here. That's it. Do you guys agree with that? There's only 1 orange shirt out there. And so the question is, what's the probability that it's a shirt given that it's orange clothes? Well, if I told you it's orange clothing, how many shirts are orange clothing? Well, just 1. So that's why it's 1. Oops, let me change that back. It's 1 over 1, which is 1. Of course, it's 100% probability. If I told you it's a piece of orange clothing, you know it's got to be a shirt because it's the only orange clothing I have. Okay? Okay, the probability of green clothes given pants. So let's take a look at that. Given that it's pants, so I know it's a pair of pants. How many pants do I have? I have 2 pair of pants. So my denominator is 2. And my numerator has got to be green pants. So it's again, it says probability it's green clothes given it's pants. I know it's pants, so how many green pants do I have? None. So there's no. It's probability 0. Probability that it's of pants given that it's blue clothes. So I'm telling you it's blue clothes. So let's go back up there. I'm telling you it's blue clothes, which means it's either blue tie, blue shirt, blue pants, or blue shoes. So 1, 2, 3, 4, 5 blue items. So 5 blue items, and what's probability that it's pants? Well, let's look at pants. There's only 1 pair of blue pants. So it's only 1/5. Okay? The probability, now this is different. Now it says probability of blue clothes and ties. So it has to be, both have to be true. Both true. Okay? So if both is true, blue clothes and ties, let's take a look at it. Let's see, blue clothes and ties. So in other words, a blue tie and a blue tie are the only ones, and that's out of what? It's actually out of the total amount. There's no given here. So it's out of the total amount, so it's actually 2 out of 11. Okay? Red clothes and pants. So let's take a look at red clothes. So pants, do you guys agree there's 1 pair of red pants? So the answer is just 1/11. All right? Now we got or. Blue clothes or ties. So probably getting blue clothes, go back up here. Probably getting blue clothes is 5/11. Okay, and then probably getting a blue tie, there's 4 of them, so it's 4/11. So let's write that out here. It's 5/11 plus 4/11. And then now what do you have to do? I counted clothes, blue clothes and ties, I counted that twice. Right here. Okay, and remember what I told you to do. If you count it twice, you got to subtract the overlap because I counted it 2 times. So I basically subtract 2 11s because I counted it twice. And so that gives me 7 11s. Okay? Okay, so then the last one, probability of green clothes or pants. So probability of green clothes. If I look back here, I have a green shirt here and a green tie, right? So it's 2 out of 11. So 2 over 11. Probability of pants. Okay, there are 2 pair of pants, right? So 2 over 11. And then again, I got to subtract my overlap, and that's green pants. So I look back up here. I don't have any green pants. These are my only pants right here. I just blue and red. So there's no overlap. So that's the answer. So it's equal to 4/11. Because this was my overlap because I had blue ties. And this is no overlap. So 4/11. Okay? So that's pretty much it, math fans. This is conditional probability, again, using the formulas, also just using logic with the charts, and hopefully we're good to go with the stuff. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.